Hey everybody, I wanted to go ahead and do one of the problems that had a p-value in it. There was a couple of questions about p-value. We did cover how to turn a z into a p in Module 4, but I figured I'd go through in Excel and show you guys how to do it once more. Okay, so I'm looking at problem 3 here. Physicians in a clinic gave what they thought were drugs to 970 patients, although the doctors later learned that their drugs were really placebos. Normally, placebo is like a sugar pill. 51% of the patients reported an improved condition. Assume the placebo is ineffective. The probability of patients' condition improving is 46%. Test the hypothesis that the proportion of the patients improving is greater than 46%. Okay, so we've got our problem there. I'm going to break this up into two screens. Got our problem there. Let's see if we can identify a few of our different things. First thing is sample size. Sample size here is 970 patients. Next thing I want is the P, the proportion, the population parameter. That is the 0.46. And the p-hat, the test statistic, or the point estimate, would be 51%, so 0.51. Cool. All right, so let's go ahead and write a null and alternative hypothesis. So I got my H0 and my HA. So the P is going to be equal to 0.46. Remember, the null hypothesis is always equality. So what I'm really hoping for is that I get to reject the null hypothesis. That's always what our goal is in a hypothesis test. And we're able to say, actually, we think the proportion is greater than 0.46 because we just tried this placebo test and we came up with 51%. That is greater. So that's our null and our alternative. Then let's go ahead and compute a few other things. We have our standard error. Remember, our standard error is the square root of the p times 1 minus the p, all divided by n. So I wrote the little equation there. I'm going to go ahead and do it. SQRT. There's my p. I'm using the p, not the p-hat. Sometimes that's a mistake students will make. There we go. And then divide by the n. There we go. So that is my SE. And then let's write my Z here. My Z is the p-hat minus the p, all divided by the SE. So to do that, I just take my p-hat. Sorry, I need parentheses, don't I? I take my p-hat, I subtract my p-value, close my parentheses, and I divide by my standard error. So a pretty large z-value. All right, let's double check that's right before we compute a p. No sense in doing that before we get to a p. Let's check. You can click submit. You have infinite submissions of these problems anyway, but I just check for the moment. Okay, cool. I got that right. So now I need to convert the z into a p-value. Okay, for this one, this is a one-tailed test. So I'm just going to convert the z directly into a p. No weird doubling thing going on here. Remember, if you have a two-tailed test, sometimes you have to double it. So the command here was norm.inverse. No, sorry, other one. Norm.dist. And I'm going to use the s.dist because I just have the z-score here. And we want the cumulative to be true. So it gives me a very small p-value there. And that is going to be what I copy and paste here. Sorry, so I stopped it there for a second. I figured out what I did wrong. I wanted it to be true here, and I didn't actually type that in. So I needed to type that in, that it is true. You always want it true on this norm.dist. I just didn't type it, so it came out false. Okay, so that gives me this as my p-value. Now, this is a very high p-value. It's everything that's lower than a z-score of 3.12. That is not what I want. I want 1 minus that value so that I just pick up the tail where the proportion is greater than 0.46. So this then is my p-value, not that original thing. All right, now let's hit submit, see if we get that big old green bar. There we go. So I did have a little error there. Sorry about that, guys. I needed to type out true. I was moving too quickly here. Trying to keep these videos short. Okay, so again, to the Z, the SE and the Z we've seen before. And then the conversion for the P, we've also seen it's doing that norm.s.dist, taking the Z and converting it over. Do keep in mind that you have to get the right tail, the correct tail, which in this case happened to be the right tail because I want it to be greater than. Sometimes we might have to do little weird things like double the p-value, especially when it's two tail, when it's not equal. Okay, guys, keep working hard.